Hi everyone. In today's video, I am going to be talking about employing a sampling strategy and determining the appropriate sample size. You need to adopt a strategy for gathering your sample. There are two main ways to go about it. The first is to use a strategy for random selection, and the second is to use a strategy that aims to strategically select your sample in a non-random fashion. The best method will depend on a number of factors, including the nature of your question, the makeup of your population, the type of data you wish to collect, and your intended mode of analysis. So what is random sampling? Random sampling relies on random selection, or the process by which each element in a population has an equal chance of selection. For example, names drawn out of a hat, or computer-generated random numbers. The process attempts to control for researcher bias and allows for statistical estimation of representativeness. If it is random, then there is no question of bias here, right? The process, however, demands that all elements of a population are known and accessible, and that all elements are equally likely to agree to be part of a sample. If this is not the case, two types of error can occur. The first is coverage error, or the situation in which the list you draw your sample from is incomplete. For example, while every name in the hat has an equal chance of being drawn, all the names need to be in the hat first. Surveys reliant on email addresses can have this problem. Unless everyone in a particular population has email, coverage is likely to be incomplete. The second type of error is non-response bias, or the situation in which those who accept an invitation to be in a sample are somehow intrinsically different from those who decline. For example, in conducting a customer satisfaction survey, it might be that those who agree to participate actually have a complaint to make, an axe to grind. If this is the case, your eventuating sample will not be representative of your population. You will be missing out on those people who have something positive to say. It is therefore important to consider whether the list you draw your sample from is complete. If this is not possible, you will need to think about how you can give a voice to any sector of the population that might miss inclusion. You will also need to explore issues of non-response and come up with strategies that will ensure broad representation. So what are the different types of random sampling? The first one is simple random sampling. This involves identifying all elements of a population, listing those elements and randomly selecting from the list. Here, all elements have an equal chance of inclusion. This is considered a fair means of selection and it allows for generalization. This is rarely used in practice because the process of identifying, listing, and randomly selecting elements is often unfeasible. Resulting samples may not capture enough elements of particular subgroups you are interested in studying. The second type is systematic sampling, which involves selecting every nth case within a defined population. For example, going to every 10th house or selecting every 20th person on a list. This is easier to do than devising methods for random selection. It offers a close approximation of random sampling as long as elements are not in a particular order. For example, you would not have a random approximation if you were to go every 10th house, which just happened to be always a standalone home or the corner in a neighborhood with lots of duplex. The third type is a stratified sampling, which involves dividing your population into various subgroups and taking a random sample with each one. This ensures that your sample represents key subgroups of the population, for example, males as well as females. Representation of the subgroups can be proportionate or disproportionate. For example, if you want to sample 100 nurses with a population of 80% females and 20% males, a proportionate stratified sample would be made up of 80 females and 20 males. In a disproportionate stratified sample, you would use a ratio different to the population. For example, maybe using 50 males and 50 females. Stratification can be used in conjunction with systematic as well as random sampling. The fourth and the final type of random sampling is cluster sampling, which involves surveying whole clusters of population. Clusters can include schools, hospitals, regions. Clusters are sampled so that individuals within them can be surveyed or interviewed. The thinking here is that the best way to find high school students is through high schools. The best way to find hospital patients is of course through hospitals, often conducted in multiple stages. For example, if your population is hospital patients in Australia, you would use a random sampling strategy to select regions across Australia. Then use a sampling strategy to select a number of hospitals within these regions before employing another sampling strategies to select your final patients from these selected hospitals. Full population lists are not required and eventuating samples can be geographically contained. So the second type of sampling is of course non-random sampling. They are samples that are not drawn in a random fashion and are sometimes called purposive or theoretical samples. In order to generate a sample that is meaningful and possibly representative, non-random sampling demands conscientious decision making. Now, non-random samples are considered by some to be inferior because they cannot be statistically assessed for representativeness. They are sometimes seen as second best or the last resort of a researcher. There is a growing belief, however, that there is no longer need to apologize for these type of samples. Researchers use non-random samples can generate meaningful samples and even credibly represent populations if selection is done with the goal of representativeness in mind and strategies are used to ensure that samples match population characteristics. Certainly, non-random selection offers researchers flexibility when working with populations that are hard to define and or access. For example, homeless women or sports people who have used steroids. There is, however, an added burden of responsibility in ensuring that evaluating samples are not biased. Specifically, researchers who are after representativeness need to be aware of unwitting bias. Unwitting bias refers to the tendency to unwittingly act in ways that confirm what you might already suspect, something that can be quite easy to do when you are handpicking a sample. For example, you may want to conduct a focus group that can help evaluate an initiative you have started in your workplace. Unless you make a conscious decision to do otherwise, it's just too easy to stack the deck in your favor. The other thing the researcher has to be aware of in non-random sampling is erroneous assumptions. Erroneous assumption is somewhat different and refers to sample selection that is premised on incorrect assumption. For example, that you can go to the local McDonald's to select a representative sample of teenagers in a small town without realizing that a certain sector of that town's teenage population wouldn't be caught dead there. You might also make erroneous assumptions about the characteristics of elements within your sample. For example, you want to study teenage anger and you select what you believe are extreme cases of anger. If your assumptions are incorrect and what you see as extreme is actually quite average, the generalization you make will not be valid. Now, in order to control for these biases, it is well worth brainstorming your own ideas, assumptions, and expectations as they relate to both your research question and your sample. This will put you in a strong position to work towards the development of an appropriate sampling strategy. Now let's discuss what are some of the non-random sampling strategies. The first one is hand-picked sampling, which involves the selection of a sample with a particular purpose in mind. Representativeness will depend on the researcher's ability to select cases that meet particular criteria, including typicality, wide variance, expertise, etc. Other options include the selection of critical extreme, deviant, or poetically important cases. While not likely to be representative, the selection of such cases allows researchers to study intrinsically interesting cases or enhance learning by exploring the limits or boundaries of a situation or phenomena. The second type is a snowball sampling, which involves building a sample through referrals. Once an initial respondent is identified, you ask them to identify others who meet the study criteria. Each of those individuals is then asked for further recommendations. This type is often used when working with populations that are not easily identified or accessible. For example, a population of homeless persons can be hard to identify, but by using referrals, a sample can build quite quickly. Snowballing, however, will not guarantee you representativeness. An option here is to develop a population profile from the literature and assess representativeness by comparing your sample to your profile. Volunteer sampling involves selecting a sample by asking for volunteers. For example, you can put an ad in the newspaper or go into local organizations such as school or community groups. I'm sure if you are in the research area, you must have got invitation to be a volunteer respondent to many surveys or research. While convenient, it is not likely to be representative. The characteristics of those who volunteer can be quite distinct from those who don't. Arguments for representativeness will rely on strategies used to minimize this difference between volunteers and the rest of the population. You eventually have to justify that the volunteers did make up for the representativeness of the broader population in general. Finally, I want to talk about convenience sampling, which many people say that is not the best one for credible research, but I kind of disagree. I feel that any sampling strategy depends on your research question. It depends on the problem you're solving, the data you're trying to collect. So there needs to be more to a sampling strategy than just convenience. Yes, limited time and resources may make convenience one factor in sample selection, but still many people believe that convenience sampling has no place in credible research. I, however, do not agree completely. I feel, yes, of course, it is the last form of or the last resort for a researcher, but if it helps you to collect the data that helps you to answer your research question and there is no place for bias there and you can show objectivity, why not? Go for it. I have been guilty myself of using convenience sampling. But I leave it to you guys. Like I said before at the very beginning of the PowerPoint, that your sampling strategy will depend on your research problem, the questions you are trying to answer, and the makeup of your population, the type of data you wish to collect, and the intended mode of analysis. So guys, keeping the video short, I will finish it now, and let me know what you thought about this video, and I will see you soon with my next video. Bye for now.